Every building needs a frame, a skeleton to hold its form. In a cell, this framework, the cytoskeleton, maintains its shape and organizes its internal functions. The stiffest component of the cytoskeleton is the microtubule. Microtubules don't just preserve the shape of the cell, they also provide intracellular tracks along which motor proteins can travel and transport cargo. In this sense, you might think of them as protein highways. Unlike rigid roads, these highways are dynamic. Microtubules keep assembling and disassembling, growing and shrinking. They suddenly switch from a phase of growth to rapid shrinkage, an event known as a catastrophe. If the shrinking microtubule begins to grow again, this switch is called a rescue. This back and forth between catastrophe and rescue composes a molecular symphony called dynamic instability. Far from chaos, it is a precisely orchestrated duet that empowers the cell to adapt, reorganize, and respond to change. In neurons, microtubules span the entire length of the axon, forming toll-free expressways that enable the rapid delivery of proteins and signals. But when something goes wrong, say, if essential stabilizing proteins fail to interact properly with microtubules, these highways can collapse, a catastrophe without rescue. Signals can no longer travel efficiently. This breakdown in cellular transport is associated with neurodegenerative diseases, including Alzheimer's. Your memories, once traveling smoothly down these tiny highways, may become lost in the rubble of collapsed routes, difficult to access, impossible to recall. The elusive world of wonder, so tiny that light can't reveal it. To see it, you must hurl electrons instead. Under cryogenic conditions that freeze its constant motion, you can see microtubules in the cell, captured in a family portrait alongside the membrane, mitochondria, and vesicles. To visualize microtubule growth in neurons, end-binding proteins can be tagged with fluorescent markers, allowing photoactivation movies to capture a zoomed-out view of their dynamic behavior. Through simulations, you can witness subtle nuances and atomic resolution unfolding before your eyes, something you can't see by microscopy. The motion of tubulin tails, the intricate interactions between each building block, the subtle asymmetry at the seam. You can travel inward, walk alongside the lattice as if you were a protein, part of the symphony itself.
از کجا آمدم آمدنم بهر چه بود به کجا میروم آخه ننمایی تنم ماندم سخت عجب کس چه سبب ساخت مرا یا چه بوده است مراد وی از این ساختنم مرغ باغ ملکوتم نیم از عالم خاک چند روزی قفسی ساختند از بدنم
اگر در خانه امیری شوی که به نقش و گچ کنده کرده باشند روزگاری دراز صفت آن بینی و تعجب کنی و همیشه در خانه خدایی و هیچ تعجب نکنی و این عالم اجسام خانه خدای است و فرش وی زمین است و خزانه وی کوه‌ها و گنجینه وی دریاها و چراغ وی ماه است و شعله وی آفتاب و قندیل‌های وی ستارگان و تو از عجایب این غافل که خانه بس بزرگ است و چشم تو بس مختصر و در وی نمی‌گنجد و مثل تو چون مورچه‌ای است که در قصر ملکی سوراخ دارد جز از سوراخ خویش و غذای خویش و یاران خویش هیچ خبر ندارد اما از جمال صورت قصر و بسیاری غلامان و سریر ملک و پادشاهی وی بیخبر است اگر خواهی که به درجه مورچه قناعت کنی میباش وگرنه راحت داده اند تا در بستان معرفت حق تعالی تماشا کنی و بیرون آیی چشم باز کن تا عجایب ببینی که مدهوش و